Welcome to the geometry video instruction. I'm David Ballard. I wrote an Algebra 1 book. You may or may not have gone through that course and watched that set of videos. We'll be referring to that algebra book a good bit during the course of this study. You may find that Algebra 1 book online at www.dballardproductions.com. www. That was pretty. www.dballardproductions.com. There's an algebra tab. You click on the algebra tab. You can find Algebra 1 Student Edition, Chapter 1, whichever chapter you want. So I will be making lots of references again to that textbook, and you can go there to find the reference pages that I'm referring you to. We're going to begin Chapter 1. We're looking at points, lines, planes, and angles. We're going to get some basic definitions that we need for geometry, and we're going to build some basic postulates and theorems. We will start Chapter 1 with some pre-Chapter 1 skills practice. This will be learning to convert units of measure using dimensional analysis. We will learn to add, subtract, multiply, and divide fractions, decimals, and mixed numerals, just to review that. We will look at solving some basic algebra equations that would have come out of Algebra 1 to make sure we can do that, and kind of introduce some basic word problems. We're going to begin then the study of geometry with points, lines, and planes. Those are undefined terms. Undefined terms. And then we will use those undefined terms to make some definitions. As we learn definitions in this course, it will be very important that you memorize those definitions word for word and be able to visually think about what they mean and on paper draw a picture. Most of the time, a definition in geometry will be a blueprint of how to draw a particular geometrical shape or a geometrical concept. We will define an angle. We'll talk about different classifications of angles, acute, right, obtuse, some things you've been familiar with in the past, and expound upon those things. And then we will begin to make rules in geometry. There's two types of rules that we'll talk about, postulates and theorems. Theorems will be rules that are based upon rules that we've already learned before, to where we can take several things and say, well, because of this rule, we can conclude this, and because of another rule, we can conclude that. And when we put all these things we can conclude from these rules together, we come up with a new rule. That would be a theorem, a rule based on other rules and logical thinking. There's some rules that we won't really be able to build off of other rules necessarily. We would build those rules based on experimentation or observations. And we call those postulates. They're not things that we prove based on other rules. They're things that we logically conclude from trial and error experimentation type of things. At the end of each chapter are the odd answer solutions, and they're totally worked out. It's not just the answer. It's like a solutions manual. There's a study guide that will look like the test. What I have for each chapter is I have the study guide, and then I have a homework that covers the whole chapter, and then I have a test for the whole chapter, and then I have a retest for the whole chapter. So there's 4 things that are going to look alike to help you prepare for a chapter test. The study guide, the homework sheet for practice, or the practice sheet, then a test and a retest, okay? All right, so we're going to begin with the pre-chapter skills and practice. And so here we go to pages 1 and 2. The first thing we're going to investigate are conversions. You may have learned to convert from one unit to another by saying if you go from large to small, you multiply, or small to large, divide. And you should familiarize yourself with the metric prefixes. Kilo is 1,000, hecto is 100, deca is 10. Your ones place, your basic unit, meter, liters, and grams. Meter is length, and liter is volume, and gram is weight. You should be familiar with those. Deci is the tenths place, centi hundredths, and milli thousandths. There's 10 milli in a centi, 10 centi in a deci. If you go from milli all the way to deci, that's 100. If you go 3 units, milli all the way to basic, that's 1,000. Milli all the way to deca, 10,000. Milli all the way to hecta, 100,000, etc. And then we also placed a few U.S. conversions that you're going to need to solve the above problems there. Instead of thinking larger to smaller multiply, smaller to larger divide, we're going to actually multiply every single time using what we call dimensional analysis. We will be using dimensional analysis because it's going to lead into the concept of scale, which we will use with similar triangles in Chapter 7. And it's the method that science uses to help solve their scientific equations with mathematical background, obviously. Okay? And so we want to have our courses working together as much as possible. So I'm going to work a few of these just to make sure we have the basics of that down. I'll leave our units of measure showing there. And I'm just going to take out some of the middle so we'll have a place to work. Let me get some of this out of here. Okay. Now, here's what we do as we try to show our work. When we're using dimensional analysis, we're going to take what we start with, we say, and we're going to multiply that by our scale factor. So what we're starting with here is 24 millimeters, and we're going to put it over 1 to make it a fraction, and we're going to multiply by a fraction. That thing we're multiplying by, we could call the scale factor, conversion factor. Here's the way we do it. We're going to say that we're going to multiply such that we lose the name milli and gain the name centi. So watch it in the fractions. We lose the name milli, so we need a milli on the bottom that would cancel the milli on the top, and gain the name centi. And so then we use our conversion. 1 centi would be 10 milli. 1 centi is 10 milli. When you multiply the numbers, numerators, 24 centimeters. Multiply the names, denominators, 10. When you divide by 10, it moves the decimal 1 place, and so you have 2.4 centimeters. 2.4. Let's see, we got that. This process of multiplying so that you lose the name you're trying to get rid of and gain the name you're trying to gain so that they cancel like that is called dimensional analysis. Okay? All right. Number 2. Number 2, we're going to use that same concept. We're starting with 36 inches. We'll put it over 1. And we're going to multiply such that we lose that name we're trying to get rid of, inches, and gain the name feet we're trying to go to. We look at our conversion. 1 foot is 12 inches. 1 foot is 12 inches. We can cross-reduce the numbers. 12 goes into 12 once. 12 goes into 36 3. So then we multiply. 3 times 1 is 3 feet. We've got a 1 on bottom, which is just 3 feet. Any questions on number 2? Dimensional analysis to convert. Okay. Okay, we're going to go ahead and do number 5 and 6. Number 5 and number 6. So I'm going to move some of this out of the way so we'll have room to work. So we're going to start with 106 millimeters, and we're going to multiply such that we lose the name millimeters and gain the name decameters. And so we would look at our conversion, and we had kilo, hecto, deca, the basic unit, deci, centi, milli. When you go from milli to deca, it's 10, 100, 1,000, 10,000. 1 deca is 10,000 milli. And then we're going to multiply 106 deca over 10,000. When you divide by 10,000, move your decimal 4 places. So you're going to have 0.0106 decameters. Any questions on number 5? Number 6, we're starting with 21 feet. We want to lose the name feet, gain the name yards. We know that 1 yard is 3 feet. 3 goes into 3 once. 3 goes into 21 7. Multiply the numerators or numbers, 7 yards over 1, 7 yards. Any questions on using the dimensional analysis approach to converting units of measure? Again, it's very important to learn this process. It is the process that we're expected to use on most standardized testing today, and it ties right into scaling up and scaling down as we look at similar figures. It ties right into dilations as we enlarge or reduce geometrical shapes on a coordinate plane. And it ties right into solving equations involving units in chemistry and physics and those types of courses. Okay. The next thing we're going to do is take a look at adding, subtracting, multiplying, and dividing fractions and mixed numerals. To think about this, we really need to go back and think about the Algebra 1 book. On page 1 of the Algebra book, it says to add or subtract. The names have to be the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator. So on page 1, we said to add, the names have to be the same. On page 8, of the algebra text. On page 8 of the algebra text, we talked about adding and having to find common denominators. We learned on page 5 of the geometry text that to multiply or divide, the names do not have to be the same. They do not have to be like terms. Every time you multiply or divide, you get a new name. And to multiply, you multiply the numbers and you multiply the names and you get a new name. And then we learned that when you divide by a fraction, you reciprocate and multiply. That divide by a fraction, reciprocate, and multiply is on page 7. So in the Algebra 1 textbook, pages 1 through 8 will cover adding, subtracting, multiplying, and dividing fractions and mixed numerals. It'll also cover the decimals down here also. So all of this material right here you will find on pages 1 through 8 of my Algebra 1 textbook. Okay, so we're going to go back and focus on question number 9. We're going to say those basic common sense rules as we go. To add or subtract, the names have to be the same. In algebra, we call them like terms. So we line up our like terms, our wholes being lined up with our wholes, and our fractional part being lined up with our fractional part, and then we would add. But you cannot add unless the name is the same. In algebra, we call them like terms. With fractions, we say that we need a common denominator. Page 8 of the Algebra 1 text says, to find the common denominator, you find the least common multiple. It shows you the prime factorization method of finding the least common multiple. And so you might want to study that on page 8 if you get larger denominators. We probably should all know that the common denominator there would be 4. When we look at multiples, not the way it teaches it on page 8, but what multiples are, the multiples of 4 are 0, 4, 8, etc. The multiples of 2 are 0, 2, 4, 6, etc. The least common non-zero multiple is 4. That's the common denominator. If they get big and yucky, then you need to use the prime factorization method on page 8 of the text to find those. Once we know what our common denominator is, we make equivalent fractions. And so we say 4 times what is 4? 1. So 1 times 1 is 1. 2 times what is 4? 2. So 1 times 2 is 2. We make equivalent fractions. And then we add one of those little fourths plus 2 of those little fourths makes 3 of those little fourths. And then we add our whole numbers. 3 plus 2 is 5, and we have 5 and 3/4. Any questions on number 9? Okay. Okay. Number 10. In the algebra text, we learned about turning words into mathematical symbols on page 37. And when we did that, we learned that that little word of means times. So 1/3 of 4.5 means 1/3 times 4.5. On page 5 of the algebra text, we said to multiply, you're going to multiply the numbers and you multiply the names and you get a new name. On page 1, we talked about numbers and names. And we said that the name was the denominator and the number was the numerator, one of those little thirds. The name of the second fraction is halves, and we need to know how many of those little halves we have. We talked about this logically on page 5 of the algebra book. We said what we really have is 4 sets of, we know that one whole is 2 halves, so we have 4 sets of 2 halves plus 1 half more. 4 sets of, that's the same as multiply, so we're going to have 4 times 2 plus 1. And the way y'all learned this was just to say 4 times 2 plus 1. What we're really thinking is we have 4 sets of 2 halves, which would be 8 halves, plus 1 more half is 9 halves. Or 4 times 2 is 8 plus 1 is 9. Here's the logic. Here's the trick. We see we got that. Now, before we multiply the numbers and multiply the names, we could cross reduce. 3 goes into 3 once, 3 goes into 9 3. Then we multiply the numbers remaining 3, multiply the names remaining 2, and simplify. It's acceptable a lot of times in higher level mathematics to leave it improper because we'll plug it in algebraic applications a lot of times, and we'll want it as an improper fraction to do so. But for this lesson, we wanted you to go ahead and make it a mixed numeral. So we take the numerator 3 divided by the denominator 2. It'll go 1 time. We get 1 times 2 is 2 with 1 left over. You put that remainder 1 over the divisor 2, and you get 1 1/2. So the answer there, 1 1/2. Any questions on number 10? Okay. So we've looked at addition. We've looked at multiplication. Let's take a look at subtraction. A little house cleaning there. So the operation is subtraction. Page 1 of the algebra book, to add or subtract, the names have to be the same. So as we go to page 2 and so on, we learn that we line up our like names, wholes with wholes, and the fractional part with the fractional part. And then we got to page 8 of the algebra book, and we said to add with fractions, we need the common name, which would be a common denominator. We taught you on page 8 how to find that using the least common multiple prime factorization method. And we would find here that it is 6. We would then make equivalent. So we say 6 times what? 1. So 1 times 1 is 1. 2 times what is 6? 3. So 1 times is 3. We're trying to subtract. We have 1 of those little 6. We're trying to take away 3 of those little 6. If you only have one thing in a bucket, you can't take 3 of them out. So we cannot subtract 3 sixths from 1 6. We don't have enough. So we need to get some more sixths. The place we're going to go get them is the next place value position over, which is the whole numbers place, and it'll reduce the 3 to a 2. And we ask the question that one whole that I borrowed is equal to how many sixths that I'm trying to get. And we know that one whole is 6 sixths. So we borrowed one whole, which is 6 sixths, added to the 1 6 that we already had, now gives us 7 6. Now we've got 7 in our bucket, which means we can take out 3. So 7 of those minus 3 of those leaves 4 of those little sixths, which will reduce to 2/3. And then 2 wholes minus 1 whole leaves 1 whole. So the answer is 1 2/3. Any questions on number 11? On page 2 of the algebra text, it says, to carry or borrow, you ask the question, how many of these things I'm trying to borrow does it take to make one of those things that I borrowed? In other words, I borrowed one whole. How many sixths is that? It's 6, 6. So I add the 6 6 to the one that I already had, which now gives me 7 6 minus 3 6 is 4 6, which reduces to 2/3. Okay? All right. Number 12. Well, yes, we'll do number 12. Number 12, if we make these improper fractions, we would say 5 times 8 is 40, plus the 1 is 41 eighths, divided by, to make a whole number a fraction, you put it over 1, so we have that. And then there's a rule about dividing by a fraction, and that rule's on page 7 of my Algebra 1 book. It has nothing to do with the 41 eighths. It has to do with the dividing by the fraction 2 over 1. It says to divide by a fraction, you multiply by the reciprocal. So to divide by the fraction 2 over 1, we multiply by its reciprocal 1 over 2, and we leave the 41 eighths alone because that rule had nothing to do with it. Now that it's in number, name, format, you multiply the numbers, numerators, and you multiply the names, denominators, and you get a new name. We want to change it to a mixed numeral, so we're going to take the numerator, 41, fraction bar, divide, denominator 16. It'll go 2 times. You're going to get 32 with 9 left over. You put your remainder 9 over your divisor 16, and so we have 2 and 9/16. Any questions on number 12? To divide by a fraction, you multiply by its reciprocal. Or reciprocate and multiply, I say sometimes. And we'll let you do the rest of those on your own, and we're going to move to decimals. Now, we're going to begin with addition because that's where we began the other study. Again, these rules are on page 1 through 8 of my algebra book. To add or subtract, the names have to be the same. In algebra, we call them like terms. With fractions, we line up our whole numbers with our whole numbers and our fractions with our fractions. We do the same with decimals. To do so, we line up our decimals. That would put the whole number portion with the whole number portion, and the fractional portion. There's really no difference in a decimal and a fraction. On fractions, you have to get a common name or common denominator. The name of this one is hundredths. The name of this one is tenths. To make the name the same, we add a 0, and then they'll both have the name hundredths. So we lined up the decimals, made them have the same number of decimal places, which made their names the same, and now we start adding. We're going to add in the hundredths place, 0 plus 7 hundredths is 7 hundredths. Now we add in the tenths place. 6 tenths plus 0 tenths is 6 tenths. Now we add in the wholes place. 3 wholes plus 4 wholes is 7 wholes. To add or subtract, the names have to be the same. In algebra, we call them like terms. With fractions, we need a common denominator to get our names lined up. With the decimals, we line up our names. We line up our decimals, which is lining up our names. Now, on page 5 of the algebra book, we said when you multiply or divide, the names do not have to be the same. They do not have to be like terms. Every time you multiply or divide, you get a new name. And to multiply, you multiply the numbers and you multiply the names and you get a new name. So when you're going to multiply decimals, you do not line up the decimals, you line up the digits, because it doesn't matter whether or not the names are the same. Now the rule is we're going to multiply the numbers, and so we're just going to kind of act like those decimals aren't even there. And we're going to multiply 32 times 5. 5 times 2 is 10, 0 carry your 1. 3 times 5 is 15, and 1 is 16, 160. That's multiplying the numbers. Now, if we considered the names, the name of the first one is hundredths, and the name of the second one is tenths, and hundredths times tenths is thousandths. Thousandths is 3 decimal places, and so that would give it the new name thousandths. Now watch where the trick you learned comes from. You learned a trick that says count up the number of decimal places in the factors and put that many decimal places in the product. It just so happens that the number of decimal places in the factors is the same as the number of zeros in the names of the factors. And there's going to be the same number of decimals in the product's name as there was when you add up the zeros in the factors. And so instead of adding up the zeros in the names, we're adding up the decimal places in the factors. It's the same thing. And so we've let you multiply with a trick and not ever think about the name. I think occasionally we should take the time to think tenths times hundredths is thousandths, 0.16. 0, which we know we could drop the 0 and just put 0.16. Any questions on number 20? So we've added with decimals, we've multiplied with decimals, we want to divide with decimals. So let's look at number 18. Now, we learned a little rule that says we're going to take that 6.38, that's the dividend, divided by the 0.02, that's the divisor, divided into the dividend, or we would say the dividend, 6.38, divided by the divisor, 0.02. Now, we learned a trick that says when you divide by a decimal, you move it over enough places in the divisor so that the divisor becomes a whole number. You move it the same number of places in the dividend and then straight up into the quotient. If you would like to know why, you can watch the video on page 7, the video of the lesson, page 7 of the algebra book. So once we move it, we're just going to say 2 goes into 6 3 times. You multiply, you get 6 with 0 left over and bring down a 3. Then 2 goes into 3 one time. You get 2 with 1 left over, bring down an 8. 2 goes into 18 9 times. You get 18 with 0 left over. So the answer is 319. You may go, well, how did we divide and it get huge? I thought when you divided, it got little bitty. Well, let's talk about division. What does 6 divided by 2 mean? 6 divided by 2 means to take 6 things and make groups of 2, and the answer is how many groups you get, and the answer is 3. So we're saying how many sets of 2 are in 6? 3 sets. If I had, and this isn't this problem, but it's one kind of like it, if I said 6 divided by 1/2, then what it would be saying to do is to take 1, 2, 3, 4, 5, 6 things and create sets of 1/2, not sets of 2, sets of 1/2. Now, to make a set of 1/2, we'd have to cut it in half, and 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 cut it in half. We've got 12 things. And so we learned from that that 6 divided by 1/2 is the same as 6 times 2 over 1, which is 12. And so we learned that when you divide by a fraction, the answer gets bigger because you're multiplying by the reciprocal. If we thought of that as the decimal 0.5, the answer would get bigger because you're really multiplying by the reciprocal. Okay? So what we really have is 6.38 times the reciprocal of 200ths, which is 100 over 2, which is 638 divide 2, which is 319. Okay? That's doing that same problem as a fraction instead of a decimal. That 100 is that decimal shift, and that divide by 2 is what we did after we shifted the decimal. Okay? So every trick we learn is based on some logical mathematics as we think about fractions in relationship to decimals, or as we think about the basic concept of division, which is creating sets of 2 or sets of 1/2, 1/2, 1/2, 1/2, 1/2. Okay? All right. I'm going to leave the rest of those for you, and we're going to move into some algebraic examples. When we look at the algebraic examples, then the order of operations horseshoe is not a part of this textbook. It's in the preliminary pages, hidden in some stuff there maybe. But it's on page 33 of the Algebra 1 book. And the way I teach it is this. I say parentheses, exponents, multiplication or division from left to right, addition or subtraction from left to right. And we use the acronym here, please excuse my adherence, Sally, because it's so universally accepted. And then there's 3 parts to the horseshoe. We say, is there anything that you can do to simplify the expression in the order, please excuse my dear Aunt Sally. And when you get to multiplication and division, we say looking for distributive property. So we're going to do anything we can to simplify the expression in the order, please excuse my dear Aunt Sally, looking for distributive when we come to multiplication and division, and looking for combining like terms when we get to addition and subtraction. When we've done all we can to simplify, then we do the bottom of the horseshoe, which says get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. And then last, we're going to undo in the inverse order. Sally, Aunt, dear, my excuse, please. Sally, Aunt, dear, my excuse, please. Reverse the order of operations using inverse properties. So when I teach order of operations, I teach that horseshoe that way. So let's look at these examples, and you're going to be thinking about that horseshoe every single step of every single problem for the rest of your mathematical career. So, number one, we're going to say, is there anything we can do to simplify the expression on either side? We've got multiplication and addition. You can't do the multiplication. 2 times x is just 2x. You cannot add because you can't add if the names are not the same. Those are not like terms. So we say, is there anything we can do to simplify? And the answer is no. So we go to the bottom of the horseshoe, which says get the variable you're isolating on one side of the equal sign, parentheses, remember to change the sign when you cross over. Is the variable x on both sides? The answer is no. So we go to the last part of the horseshoe, which is to undo. The operations again are multiplication and addition. Which one do you undo first? Well, we undo in the reverse order, Sally, Aunt, dear, my. So we're going to undo addition before multiplication because, again, we are reversing the order of operations. So we're going to undo addition first using its inverse subtraction. We do that to make it cancel. What you do to the left side of the equal sign, you have to do to the right side to balance the equation. And so we're going to have 2x equal 8. Now we're going to undo multiplication by its inverse division. We're going to undo multiplication by division. We show division with a fraction bar, and we're going to get x is equal to 4. Any questions on that? Okay. Now, we're going to kind of remember that horseshoe. You may want to turn to page 33 of the algebra book, or if you have it available on the internet, or if you have a copy of it. But we're going to keep referring to that same thing the whole time. So let's just look at number 23 so we can deal with some sign rule stuff. Sign rules are on page 18 of the Algebra 1 textbook. They're in chapter 1. If you'd like to look that up. The order of operations horseshoe, page 33, was in chapter 2. So with that horseshoe, I'll keep using blue for the left and green for the bottom and red for the right, like I had it color-coded a while ago. So we say, is there anything we can do to simplify the expression on either side? You can't multiply that. You'd still have negative 5x if you tried. You can't subtract 4 from negative 5x because they're not like terms. So there's nothing that we can do to simplify. So we go to the bottom of the horseshoe and say, is the variable x that I'm trying to isolate on both sides? And the answer is no. So we go to the right side of the horseshoe, which is to undo. So we look at our operations again and say, which one do we undo first? Well, since we're reversing the order, Sally Aunt Dear, my excuse please, we would undo subtraction first with its inverse addition. And so then we would have negative 5x equal 25. Those cancel. We're now going to undo multiplication by division. You divide it by itself, negative 5, and you're going to get x equal negative 5. Now, I want to talk about something here. When you undo addition or subtraction, notice that what you're going to see is opposite signs. When you undo multiplication and division, notice what you're going to see is the same sign. Well, you may wonder why. I use the terminology that if we're going to solve for x, we're going to get the junk off of x, isolate the x. So I'm saying, okay, we're going to take off the negative 4 and take off the negative 5. We're going to undo subtraction and undo multiplication, and when it's all undone, we have x all by itself. Well, that's not really true, that x is all by itself, and it's not really true totally that we're going to get the junk off, because if we have an x that's all by itself, by additive identity, we know that there's an understood plus 0, and by multiplicative identity, we know that there's times 1. So we're really thinking, I'm not really trying to get rid of the negative 4. I'm trying to change that negative 4 to a 0, and I do that by adding 4, because negative 4 plus 4 is 0. Therefore, when we undo addition and subtraction, we're going to use opposite signs, which produce a 0, the identity element for addition. You can see all of this on page 29 of the Algebra 1 textbook, where we talk about additive identity and multiplicative identity. We're not really trying to get rid of the negative 5. We're trying to turn the negative 5 into a 1. The way you turn something into a 1 is divide that something by itself. Negative 5 divided by itself is 1. So we're going to undo multiplication and division with the same sign, basically dividing it by itself to produce the identity element for multiplication, which is a 1. Again, multiplicative identity and additive identity are taught in my algebra book on page 29 if you would like to investigate that further. The concept of undoing subtraction by addition is called the addition property of equality. That's on page 29A of the algebra text. And the concept of undoing multiplication division is called the division property of equality, which is also page 29A of the algebra text. We will talk about these properties later on in this course as we study further into the geometry course and we begin to do some proofs and things. Okay? All right, let's move on to number 26. We're going to do this one because it has a fraction, and that kind of gives some people cold chills for some reason, and we really need to get over the fright of fractions. You do need to know as you begin this class that I wrote this textbook, and then I realized my students had trouble doing constructions with rulers, measuring, and using protractors. They had trouble with fractions, decimals, and mixed numerals. So I took the major part of the whole numbers out of this textbook and changed them all to fractions and decimals and mixed numerals so that you would have to deal with that. And I created lots of construction. So don't think, well, if I don't get this fraction stuff down right now, that's going to be okay. It's not going to be okay because it's going to come back to haunt you this entire course. So go ahead and learn how to do it now so that you don't pay over and over and over later. Now, on number 26, we're going to say, is there anything we can do to simplify the expression on either side in the order, please excuse my dear Aunt Sally? You can't multiply those and change anything. You can't subtract because X stuff and numbers are not like terms. So there's nothing we can do to simplify. So we go to the bottom of the horseshoe, which says, get the variable you're isolating on side. So we say, is the variable X that I'm isolating on both sides? And the answer is no. And so we move to the right side of the horseshoe, which is to undo. So we look at our operations again, and we have multiplication and subtraction. Which one do you undo first? Subtraction by addition. So we add 6 to both sides, and we're going to have negative 4/5 x equal 24. Now, on page 25 and 26 of my algebra textbook, it teaches you how to undo addition by subtraction, subtraction by addition, multiplication, division, and square root. And on page 25, example 3, it talks about undoing multiplication, and it says, you undo multiplication, that's negative 4/5 times x. You undo multiplication by division, or, and it says something under that, it says multiply by the reciprocal. And so I taught my algebra students to never just say you undo multiplication by division. I made them say you undo multiplication by division, or, and they would say multiply by the reciprocal. So that when they got right here and they saw a fraction, and they said I'm going to undo multiplication by division, they'll automatically said, or multiply by the reciprocal. Flip it over from 4/5 to negative 4/5 to 5/4. Now remember what we talked about a while ago? When you multiply or divide, it has to be the same sign. So we need to keep that same sign, and we're going to keep it on the top. Okay? Lost part of my work here. Let me put it back. Is equal to, oh, it's coming back now. That's weird. 24. Whoops, there it is. It left me and came back. Okay. Oh, well, we'll put it back here, 24. So we're going to undo multiplication by division or multiply by the reciprocal, remembering that when you have the reciprocal, you use the same sign, and if it's negative, you put it on the top. And so we're going to multiply by negative 5/4. Now, this whole thing, negative 5/4 times negative 4/5, makes a 1. And 1 times x is x equal. Over here, 4 goes into 4 once, and 4 goes into 24 6. And 6 times negative 5 is negative 30. Any questions on number 26? So we undo multiplication by division or multiply by the reciprocal, which means flip it, but keep the sign the same. Okay? Okay. Now, I'm going to go ahead and do number 28. We'll let you do number 27 on your own. This is getting deeper into using that order of operations horseshoe that came from page 33 of chapter 2 of the Algebra 1 text at www.dballardproductions.com in case you need to see that. And so we're going to say the horseshoe. Is there anything that you can do in the order, please excuse my dear Aunt Sally, to simplify looking for distributive property and combining like terms? Now, your operations are a multiplication crammed on a parenthesis and a multiplication crammed on a parenthesis. And here's how I teach this the first time when I introduce distributive property on page 31 of the algebra text. We say here, what we would do first to the operations is parenthesis. In the parenthesis, we have subtractions. You cannot subtract those because they're not like terms. Over here, you have parenthesis. You cannot subtract what's in the parenthesis because they're not like terms. So we cannot do what's in the parenthesis. You cannot do what's in the parentheses, so we go to the next operation, multiplication. When an operation is crammed on a parenthesis, you check for distributive property. Now this is page 31 of the algebra text. It's also page 171 of the algebra text, or page 172 of the algebra text, one of those. And then we say, well, this operation, multiplication, is crammed on parentheses, so we want to check for distributive, and here's how we taught it over there in chapter 6 of the Algebra 1 text, about page 170, 71, 72, right in there. We said you can only distribute onto a one lesser operation. So an exponent will distribute onto multiplication or division. Multiplication and division will distribute onto addition and subtraction, and you can't ever distribute addition or subtraction. So multiplication will distribute onto subtraction, so we have permission according to the rules to distribute. This multiplication will distribute onto this subtraction, so here we also have permission to distribute. So we say negative 3 times 2x is negative 6x. And then negative 3 times, remember we carry the minus as a sign, negative 3. When you multiply with the same sign, the answer is a positive 9. Sign rules are on page 18, chapter 2 of the algebra text. Be sure you know those. 2 times 2x is, 2x. And then 2 times, carry the minus as a sign, negative 24. When you multiply with different signs, the answer is a negative 48. Minus means negative 48. So we always start here. We're going to do anything we can to simplify. In the order, please excuse my adherent Sally. When we get to multiplication division, we look for distributive, which we just found and did. When we get to addition subtraction, we look for combining like terms. So again, we say, is there anything that we can do to simplify either side? And the answer is no, we cannot. So that puts us at the bottom of the horseshoe, which says get the variable that you're isolating on one side of the equal sign, remembering to change the sign when you cross over. And so we say, well, is the variable x that I'm trying to isolate on both sides of the equal sign? And the answer this time is yes. So we're going to do what the bottom of the horseshoe said. Get the variable we're isolating on one side of the equal sign, remembering to change the sign, positive 2, negative 2, remembering to change the sign when you cross over. That's a negative 6. The minus on the 2 makes it a negative 2. When you add or subtract with the same sign, you add and take the common sign. Plus 9 equal the minus on the 48 means that's a negative 48. Let's see what we got there. Back to the horseshoe. Anything we can do to simplify? Nope. You cannot add those. They're not like terms. Is the variable we're trying to isolate x on both sides? No. So it must be time to undo. So So we identify our operations again. We have multiplication and addition. We're going to undo addition before multiplication because when we undo, we reverse the order of operations. We undo using inverse properties, so we undo addition by subtraction. We get negative 8x equal. The sign of the 28 is negative. The sign of the 9 is negative because minus is negative. When you add or subtract with the same sign, you add and take the common sign negative. Now we're going to undo multiplication by division, and we divide it by itself, negative 8. And so we get x equal 57 divide 8. We're going to make it a mixed numeral. 8 will go into 56 7 times. 7 times 8 is 56 with 1 left over. We put the remainder 1 over the divisor 8. And we have 7 and 1/8. When you divide with the same sign, the answer is positive. So it's a positive 7 and 1/8. Any questions on the algebraic examples, the basics of using the order of operations horseshoe? Make sure you know that also, because in geometry we will be solving a lot of equations that come from geometry applications, and we will solve those geometry problems using algebra. Okay. At the end of this, we have some basic word problems that are going to turn into adding and subtracting fractions and mixed numerals and using the skills that you had above. So I'm going to leave those for you to do on your own. That finishes the pre-chapter 1 skills and practice, and then we will be prepared to move into the heart of the geometry book, where we will begin, as we said, with the undefined terms, point, line, plane, and we will take care of that in the next recording. Thank you.